Okay, this video is how to read a distance time graph. So the first thing that I really want to stress is when a student looks at the graph, the first thing they need to do is read these words right here, because that's going to make a huge difference. This says distance right here. So whenever I'm looking at this line, whatever I want this distance to be, say it's 25, it doesn't matter. Whatever distance this is, I stay at this distance for all of this time. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. If my distance doesn't change during that time, I did not move. So that means this straight line on a distance time graph is at rest. Okay, this graph, for example, let's say this is 10, this is 5, this is 20, this is 10, this is 30, this is 15. This side still says distance. Okay, so 10 meters at 5 seconds. You can calculate that out because speed equals distance divided by time. The distance is 10 meters. The time is 5 seconds. 2 meters per second. Every time I do that, even here, 20 over 10, 30 over 15, I am still going to get 2 meters per second. The straight line on a distance time graph means constant speed. Okay? But also, I started at a distance of 0, and I am ending at whatever distance this is. I am not where I began. So I left home. In motion calculations, home is just your starting point. So I left home. I am away from home, because home is here, and I am away from home. Now, you can have different angles of lines, and that's their slope, basically. Okay? In this line right here, I am closer to getting a farther distance in a little amount of time. I like to think of it like this. Like, say we got this right here. That would be going like 60 meters in less than a second. That's fast. So the closer I am to being a straight line going up, the faster I am. So A is faster and B is slower. So this just teaches about the different angles and which one would be fast and which one would be slow. Now, you can take all the pieces and put them together in something like this. From A to B, it's a straight line, so that is constant speed. But I also left home. B to C, I'm at this distance for all of this time. So I didn't move, I'm at rest. C to D, it's a straight line, so it's constant speed. But I went back to 0. So C to D is going home or returning home. This one right here, I left home. Okay? On these graphs, speeding up and slowing down are curved lines. So When it says distance, time, it's a curved line. It's like that's slowing down, that's speeding up. We usually don't deal with these two, but the kids keep thinking that this is speeding up or this is slowing down. And that's not the case on these graphs. So those are distance time graphs, which a distance time graph would be a speed graph.